So I 100% forgot to do the intro. So yeah, question 4 of June paper 1. Here we go. Simplify the following without the use of a calculator. Okay, these are very important. It is very tempting to just put in your calculator and write down an answer. You will get exactly 0 out of 4 if you do that. So you need to know how to work with your surds basically. So this is the same story as always. You're going to go multiply with each term. So this is actually, you have to think of it this way. So you have 3 times 2 times square root 2 times square root 2. Okay? It doesn't matter which way around you multiply because of commutative law of commutative property. So this is actually 6 times square root 2 times square root 2 is 2. So this is actually 12. You can double check that with your calculator. Grab that one. No. Just have to use it cleverly. Then the rest is just normal multiplication. 12 minus 12 is 0. Don't have to worry about that. And then you treat those roots, those surds, as if they're like x's. So 3 minus 24 is negative 21, and that's a square root 2. Then again, your laws of or your properties with your square roots are very, very, very important. You can put all of this, because it's multiplication, underneath one square root. You cannot just throw them away because you don't like working with them. This is not a equation. You cannot just square and now poof, bam, there we don't have any roots left anymore. You can't do that. Okay, so then we have this x plus that square root and x minus that same square root. I want you to notice something. This is dots. Okay, still underneath that square root. So when you can multiply this out, whether you use FOIL method or the shortcut, you should be getting the first term squared minus the second term squared. Right? So x squared minus a square root squared is just whatever is underneath the square root. So you have x squared minus 2x plus 1, and then you need to see that can be factorized. Your hint is you don't want the square root anymore. You have to go as far as possible, so you have to try and factorize this. You'll see it is a perfect square. If this can simplify any further, then it has to be a perfect square. So if it's not a perfect square, you could have left it. And then square and square root cancel out, so it's x minus 1. Then again, we have these 3, okay? But each of those actually you can rewrite. So I'm going to do that part here. So you need to be able to see that 27, okay? We need to think of a square, so think about something that's a square, so which is 9 times something else. So it's 9 times 3 m to the power 6. So this is actually 3 square root 3, and then you divide this by that one that's on the outside, so 6 divided by 2 is 3. And the same we do for the other ones. Okay, 48 would be 16 times 3. Are you seeing a pattern here? Do you see it's every time times 3? So this is 4 square root 3, and it's m to the power 3, 3 divided by 6 divided by that 2. And the same with the 12. We'll have 2 square root 3 m to the power 6. Do now see all of them have something in common, so you can factorize. So these two top terms have square root 3 m to the power 3 in common. Technically, a lot of people left it as square root 3 m to the power 6. That would have given you the same answer, so it doesn't really matter. Anyway, so this first term has 3 left minus second term has 4 left. And then you have 2 square root 3 m to the power 6. What is common? Because it's a products, and products, everything is products on the top, everything is products at the bottom. They can cancel. So all you have left is 3 minus 1 is negative 1 over 2. So your answer is negative a half.